Good evening, everyone. This will just be a short sync video about the different aspects of the project for CSCI201A. Right, so the specs for these are already uploaded to Canvas, so kindly check for a soft copy there. And I'll just go through the project specs and then talk about the sign-up sheet and then talk about Latex, the format that we will be using for the final paper. So being a grad class, the requirement is to submit a paper about the subject that you are currently taking up, which is advanced algorithms, analysis and algorithms. Okay. So the objectives for the project is to allow the student to apply algorithmic concepts in solving real-world problems. That's why at the first submission, I ask you to think of a particular problem that you think could be algorithmically solved, or at least where an algorithm would help in terms of solving that problem. It doesn't have to solve the entire problem, but at least apply some sort of algorithm to solve it. Although that was quite shallow because it was very descriptive and required just a sort of a intuitive way, or an intuitive way to apply an algorithm in terms of its big O analysis. In the project, we will be going the entire mile, meaning to say that you will be implementing and analyzing these algorithms against real-world data. Okay. So the idea is that based on the topics discussed in CSCI201A, that would be our sorting, our data structures, recursion, divide and conquer, greedy algorithms, dynamic programming, recursion, of course. How can we come up with our own algorithm, analyze it, and address certain real-world problems? So it's up to you on what you want to address. You can work on the things that you've submitted in the first part, but provide some sort of algorithm process to actually solve it. The rubrics of the project will be as follows. Most of the weight will fall under implementation to actually prove that the algorithm works. Okay. I'll talk about the details a little bit later on. 30% will be the paper, which is written in LaTeX form. And then 20% will be the analysis and discussion. Okay. Also part of the paper, but I'm thinking this would also involve the last part of probably some sort of oral defense. Before the year ends. Okay, but all in all, as long as this is discussed in the paper, then that would do. Okay, the paper is really for a formality, just to make sure that we have an output with regards to being a grad class. Okay, now I decided to make 3 checkpoints, which will also serve as our sync session, so that we can also free up some time during the course, since we're only 2 months now within the year, or 2 months, a little more than 2 months before the year ends. Most of the sync sessions will involve the progress of the project itself. Okay? So the first checkpoint, I'm planning to have it by next week, which is the approval of the topic. So I did mention last time that by Wednesday next week, we will be having a submission with regards to the project, and this will come in the form of a topic. So no need to sort of have an output yet. At least have an idea by yourself or either with your partner, because again the project will be possibly by pairs, okay? Or you can do it individually, and make sure that we have a sound topic that algorithmically you can apply something to. Okay? The second checkpoint will happen sometime the second leg of November. Your proposed implementation, although I think maybe the second week of November might be a little bit too late. I'm not sure if it's quite early or too late, but hopefully it will give you time to actually perform the implementation by December. Okay? But in any case, these things are dependent on each other, meaning you cannot be approved of the proposed implementation without approving the topic first. Now, the third checkpoint is to make sure that everything is aligned with the data source that you will be using. Okay, so in order to test the algorithm, you need some data. It doesn't have to be big data. It doesn't have to be large quantities of data, as long as you have some valid examples to actually run your algorithm. And I will show a very simple example of that later on. Now, the reason why there is a model here, this is not the model in a sense of machine learning topics. It's not that case. but rather the model of how you would model your data. This mostly applies to those who would like to address problems in terms of a graph. Okay, so for example, you want to solve a particular problem that can be expressed as a graph. How would you define the nodes? How would you define the different weights for the edges from one node to another? Okay, so that's the model that I'm actually talking about here. The tentative deadline for the project will be December 15. Okay, so it will give me time to check it over the break. Okay. No word yet about the academic break next week, so let's still assume that everything is normal. So we will have our usual sync session on Monday. Okay. In any case, deadline for the project will be December 15. Now, for the outline of the paper itself, it will involve an introduction, a methodology, your typical research type paper, review of related literature. Now, this can be just quotes of something similar to the problem that you're trying to solve. Results and analysis. Now, this will include the discussion of big O analysis for different parts of your algorithm. It doesn't have to be what is your analysis on the entire thing, because usually in most real world scenarios, your algorithm will be a combination of multiple things. For example, you want to aggregate something first. You want to perform a transformation. When you perform a transformation, maybe you want to weed out some data points that are not included. Similar to our Stairway to Heaven problem, wherein you can arrange first all the possible paths. Okay, so you could perform an analysis already at that part. So provide big O analysis for every part of the problem, of the algorithm rather, that you are proposing. Okay. The analysis should include the result when you run the algorithm against a data set or a model. So this means that even just for one pass of the algorithm, what would be things like how fast would it operate? Okay, how fast would it, what would be the expected result? Okay, and what is the form of the expected result? Okay. And then, of course, the conclusion will be some insights as to how you implemented that algorithm. What is the complexity of the implementation? How you can discuss it in terms of scale. So if you were, because you're not really required to actually implement it in like the real world setting, again, can provide a very simple example of it, but how would it fare off, at least theoretically, on scaling that algorithm? Okay. And then its practicality in real world cases. Is it just to actually have an algorithm for CSCI201A, or is it something that you think would be viable for a real world implementation? Okay. So let's go into it a little bit deeper. So for the introduction, it will just be a narrative of the of what you plan to do, right? Similar to our first submission. Now, in order for it to be a valid narrative, your algorithm should incorporate at least two of the following, which is basically the topics that are covered in class, right? So we started off with sorting, and then we have divide and conquer and recursion. In a few next week, we'll be talking about graphs, and then we'll talk about greedy implementation, and then finally dynamic programming. So at least two of them should be involved in terms of your implementation, and make the discussion on the introduction in light of that. The narrative should give at least 1 to 2 sentences as to what topic is incorporated with your algorithm. Okay, so it should mention that. Okay, for example, the search domain to figure out what city to visit first given. The entire search domain, rather, to figure out what city to visit first, given limited resources for distribution, is represented as a graph where each node and edge of the graph is weighted by the city's population. Okay? So how is the problem modeled with your algorithm? Okay? On a very high-level descriptive manner. Okay? So that would be the introduction part. For review of related literature, just cite at least 5 literature papers so that we can add knowledge to the algorithm itself that you are proposing on something similar. It doesn't have to be the similar problem but at least the implementation is similar. So for example, if you're working on a graph-based problem, try to include papers that have already done some graph-based implementation. Of course, there are classical ones like Dijkstra's algorithm, although you can talk about that as well in terms of analysis, or you can model your problem as well as similar to that. But try to include at least something new. Okay? Before, I used to require something like at least less than 3 years, or sorry, at the latest 3 years for in terms of the how that related literature is up to date. But in our case, since it's an algorithm class, a lot of algorithms have already been implemented. So try to choose the one that is most relevant to your implementation. Again, it doesn't have to be about solving the domain problem, such as figuring out which city to hop on next, but rather how a related paper related to the algorithm that you are implementing, even if it's just a part of it. So just cite 5 of those and then give a short explanation about it. Now, the heavy part will actually fall in the methodology as well as the analysis. So in the methodology, you should at least provide the following sections. What does the input look like? Okay, so if you're inputting like a list of something, a queue of some sort, what would each element of the queue look like? Okay? Because in real-world scenarios, most likely these information are complex. So you might want to model it using a hash map, for example, right, to better describe the information and the data. Make sure that you also include what are the parameters of your algorithm. If there is a parameter that requires tuning, for example, in our second submission, the single perceptron algorithm, wherein you had the learning rate that you could adjust, make sure to include it there as well. And of course, what the expected output is. Okay. Explain also how your data will be retrieved and how you would model your data. Now, this can be done in 2 possible ways. If you are using existing data that you would transform programmatically as input to your algorithm, how would that data look like? So is it a CSV file? Are you extracting it from a database? Is it something that is publicly available? If it's something like a UCI machine learning dataset, so I'll provide some sources for this as well. Machine learning repository, for example, then make sure to cite it. Okay, make sure to cite it and make sure that you understand each feature that is described in the data repository. Okay. Usually there are descriptions for that, so feel free to include that in the paper. Now, if you're doing a graph-based algorithm, such as a model, if you would model the entire search space in the form of a graph, make sure that you describe how that graph would look like. Okay, what are the elements of the node, how the edges are weighted, and what does it actually mean in relation to the problem you are solving. So for example, a node in a graph is presented by a city and its population. It can be as simple as that. A node can be represented by the following object in Python. So for example, you have some sort of dictionary or hash map structure that has the following attributes. And of course, give a description of what these attributes are. Okay. Now that will be very important because in terms of implementation, you will of course need to translate that to something that is computable, something that is measurable. So if you were to, for example, transform a list of populations and then sort it from least to greatest, you will need to know what information you're looking at. Okay. So basically just provide a description of it. Okay. For each of the sections, I'll also be providing a supplementary video on how it looks like with the paper, starting with the introduction a little bit later on. Now, of course, the analysis will be your typical Big O analysis, and then some result, at least for the base case, or at least for some part of your algorithm, and running it once, for example, and then seeing what the results will be like, how the results will look like, and then what does it mean in terms of the problem. Okay? Don't worry, because this part should be answered, at least you would have an idea how to answer it at the second checkpoint. By the time you get the second checkpoint. By the time you get to the second checkpoint, rather. Okay. It doesn't have to be implemented right there and then, but at the very least, you have an idea what the expected output is. And then, of course, finally, the conclusion. All right. So if you have any questions about it, feel free again to use the Discord chat for the Discord channel to post questions there, because maybe some other individuals might have a similar question. Have the similar question. All right. So before I go to the example, one last thing. I shared this document to you. Now, you can only edit this if you are part of the, if you are using your OBF account. So I shared it with everyone's OBF accounts. So I won't give the time that that is convenient for me. So it's up to you on what time you would place here, as long as it is between working hours. Okay, meaning to say, I could start as early as 8 a.m., but not later than 6 p.m. at night. Okay, and then of course, except for our Monday sessions, but we could use one of our Monday sessions if we need to. Okay, but for now, please put in your preferred time and preferred date starting next week, and then the status here will be if it is approved or not. Meaning to say that I'll provide the different types of statuses, but basically, once you are approved, it means that there will be a scheduled status, meaning the time is already approved, and then an approved status, which means that you're done already with this checkpoint. Okay, and then you can move to the next one. If you can do it earlier, the better. So you can have everything already set, and then just worry about working with the paper, okay, just so it won't clash with your other subjects. So same format for all these 3 sheets. I will be sending the link to this again via Canvas, but you should receive a notification for it because I've already shared it with everyone in class. Okay? Now, if you're a pair, make sure to include your maybe you could merge the cells and then let me know that you're a pair by putting it here, by indicating it here. Okay. Now let's move to the sort of technical aspect of it. Since the output is paper in LaTeX format, again, there will be a series of videos that I will be sharing on how to do this. The first one is to get started with LaTeX, especially for those who are new to creating a paper in LaTeX. Now, the easiest way to get this started, I'll be providing the source code for this, is to use Overleaf. Okay, so Overleaf is an online platform that allows you to write your papers and collaborate online as well. So for example, if you're working with a partner, you could share this project, the paper document, with your partner, and you can collaborate it just like Google Docs. Now, but more importantly, you could share it with me as well, so I can take a look at the changes, and the changes will be logged, so that if there are any comments, we can weed it out early. Okay. So the format is not strict. We can use this basic format. As you can see, I don't have any template that I'm using, so it would be as simple as possible. You can use this as well as a baseline because it has all the different parts that are needed. Okay. And just a crash course for this, so you don't even need to compile because any change you make on the text editor here can also be shown on the right hand side here. Okay. So all right, so we just do a crash course on LaTeX. So LaTeX is essentially a way to programmatically define your document, and very useful for creating equations. Oh, by the way, the equation or the pseudocode, I think I mentioned it here, but I failed to describe it. The pseudocode should be included in the methodology. Here, provide a high-level overview of the algorithm using pseudocode. Or the actual code just for the main computational part. So if you're working with Python, then that could be inserted as well. Don't place your entire program inside the LaTeX document. Okay. Right. So the template is here. Very basic stuff first in terms of different sections of a LaTeX formatted document. You can also take these concepts and then apply it to, let's say, another paper that you are doing for a different class, because these stuff in this format are mostly generic. Okay, the only thing that will change will be the layout, okay, according to whatever paper you're currently working on. Right? So when we say that we have a section, okay, then you have this declarative statement in LaTeX, which often begins with a backslash. So this one indicates that you are performing a certain command, okay, or a certain command or macro in LaTeX. Okay. So each of the parts here in the paper part, so that would be introduction, review of related literature, methodology, results and analysis, and conclusion, is considered a section. Okay, so as you can see here, let me zoom in a bit. Oops. Right. So you declare a section by putting in \section and then the name of the section. Okay, so even if we had, let's say, something from scratch, just to show the sort of big picture for it. Oops. Okay. So you can delete everything here. Okay. So if you notice, if I remove this, it will compile everything. Okay, and then it will have an error because the format is not correct. I deleted too much stuff. All right. Okay, let's actually start with the begin statement. Let's wait for it to compile. Okay, I have something. There we go. Oops. Does it include the introduction? Okay, there we go. All right, so the entire body of your document actually starts with this one. So I'll start with this one instead of section. We have a begin, okay, and then the sort of name of that section. In this case, we have a top level container called the document. We begin with a document and we also end with a document. Okay. Similarly, for this particular template, the basic template that I'm using, you could also have an abstract, but in our case, we won't be using an abstract, right? But there would be a title, so the title of your paper. So the title can be given by another macro called title. So you can say \title. And if you notice, most of the values or naming your sections will be within a set of curly braces. Okay. So you could outline first the different sections of the document, just so you get a feel of how this platform works. Okay, we can actually remove this part. Okay. Don't need the abstract. And then we can start with a section called introduction. Okay. When we save this, okay, it recompiles and we have our introduction there. Okay, so very basic thing. We can add the different sections. So let's say methodology or review of related literature. And it will create the different sections of your paper. It's a basic example, right? So at the very least, you already have an outline and sort of have a pipeline on getting things to work, at least for the LaTeX part. Okay. So recap, we begin with the document. We have sort of the end tag or end macro for the document. We have a section which will create some sort of header to indicate the different sections of your paper, from results and analysis, so introduction, review of related literature, methodology, results and analysis, and of course your conclusion. Now you could have a subsection. Okay, so there's this thing called subsection, which will be a subpart of your section. Right? So let's say, let's see, pseudocode. Okay. Once you save that, you'll see that it will automatically tag it as a subsection. So you can have a pseudocode here, and then probably model of data, etc. And it will proceed to put out the different sections. Okay. So you could start working with that, and then anything here would be a paragraph. Okay, so let's look at the full example again. I think I could paste this here. There we go. Okay, so I'll share this code with a class over at Canvas. Okay. The last thing I'd like to discuss is that eventually you would have equations, okay, to represent your algorithm, or a sample run of your algorithm. So I chose this example as a basic starting point because it has a numerical example of how to describe an algorithm. Okay. It has a section in terms of what the input, or actually not even input, it actually starts, well, the input and output is actually described in the earlier sections of the sort of the process. Okay. So it models here, for example, what the expected output looks like. Okay. So let's see how that looks like in LaTeX. Okay. Every time you need to describe an equation, okay, maybe part of your algorithm, okay, you have a begin equation and an end equation. Okay. So if we take a look at the y part, okay, this part, we have begin equation, end equation, and then you have the LaTeX formatted equation in the middle. This macro will create a center aligned type of equation, okay, which is a good way to model your input and output. So if you say that you describe your input as a list of items, or a queue of items, for example, then you can easily represent it mathematically this way. Okay. So for the major parts of your algorithm, specifically what the input looks like, what the output looks like, you can use this equation macro. Okay. Now, at some points, you might want to describe the different sections of your equation. For example, in here, we have what y1 is, what y2 is, and what y3 is, as well as a numerical example. These equations are embedded inside your paragraphs, or they are in line with the description or the content of your paper. So if that's the case, the simplest way to do that is to insert it in between dollar signs. So you can see here, y sub 1, so y underscore curly brace 1, this figure is in between dollar signs, and it will automatically treat it as a math equation. Okay. So you could go through the other parts of this paper, and if you read through the training part, this is actually an extension of the single perceptron algorithm, but with a numerical example. So this is what I mean by you could just give an example of a single run, wherein each point of the run will see how your data transforms throughout each part of the algorithm. Okay. I start off with some initial values, and then it explains the different parts of the algorithm, what equations are used, how it's mathematically represented, all of which are using basic begin and end equation macros. Even the numerical examples would show the computation of what happens if I input this type of input and what the expected output is. Okay. So it may be a bit lengthy, but it's littered with all the basics of LaTeX. And at least for this week, just go through the entire paper and see how the notations are used in the different sections. Okay, we only discussed two things here. The section, okay, of course the content are just paragraphs, and then how to make use of an equation. Okay, So try to get familiar with the platform. I'll try to share some other videos on how the other LaTeX part works. The LaTeX parts work. For example, pseudocode. If you wish to go to the pseudocode part, but at least this first example will give you an idea on how the paper should be laid out and an example of what the methodology of the algorithm might look like, which is a huge chunk of the paper. Okay. All right, so please do not forget to start signing up for the project sign-ups starting next week. I'll also send an email with regards to this. And right, and I'll see everyone on Monday again. Okay, keep posted as well in Discord and emails if I have some extra announcements with some supplementary materials that you could check out. Right? Okay, so that's it for now. I'll see everyone on Monday next week. All right, thank you.